going over probability and using relative or experimental probability. So before we start, quickly, probability is what you want over all the different outcomes. It can be written as a fraction, decimal or percentage, and key thing, all probabilities add up to 1. Now, to explain about relative frequency or experimental probability, you have something called theoretical probability as well, which is, say if you've got a dice, it has 6 sides, it has a 1 out of 6 chance for every single side. But experimental probability will be when you actually roll the dice, say 100 times, does it come out being, around 1 out of 6 as a fraction at the end for each side? And then relative frequency relates to that. It'll be, say you're doing a survey of something, which is similar to the examples you'll see. And it's based on that, what's the probability of someone liking something? And that's kind of what we're going to look at now as well. So here we go. We've got 100 people are asked how they get to school. Now, you've got car, bus, train, bike, and walk. So for this, you want to, we're going to put the relative frequency of each of these happening. So we'll start off with the car. So you've got that, it's 35 people actually do it. So that means a relative frequency, your experimental is 35 over 100. And you can write that as a decimal as well. I'm going to write both for this because later on it does help out. So bus, we got 39 out of 100, 39 over 100. And again, as a decimal, 0.39. Train, we got 10 over 100. So we can say that is 0.1. Bike is 9 over 100. So we got 0.09. And then finally, walk, 7 over 100. 0.07. I encourage more people to walk at this rate. Anyway, if we look at what problems would look like. So that's how you fill out maybe a table that you'll see or calculate things. So what you might see here is what's the probability that someone takes the bus. Now, this is quite nice because we've done that hard work there. Take the bus, 39 over 100. Or 0.39. We could just write either of those there as an answer. So 39 over 100 or 0.39. Just write that there. Okay, someone walks or bikes in. Now that is, you can start using the OR rule there because you've got OR, which means addition. So walks, if I look there, it's 0.07. And you're adding the bike, which is 0.09, and it gives you 0.16. So that's the probability of someone walking or biking. And now, probability that someone doesn't go by car. So not by car, that means all these ones added up because you don't want the car, or 1 minus the top one. So I'm going to go for that option, which is 1 minus 0.35, and that gives you a solution of 0.65. So that calculated some probabilities using our information there. Now what you could get with this is something like that. If 500 people were asked, how many do you expect to go by train? Now what that means is you can use that information there and make an estimate, because it's not the actual answer. You never know until you actually do an experiment, and always the more trials you do, the more likely, more accurate your probabilities will be. So what you want to do for that is you take how many people you're asking, so 500, and then multiply it by the probability for that event. So train is 0.1, so you do 500 multiplied by 0.1, and you do that, and it'll give you your solution. So here we got 50. So 50 people we assume go by train, okay? And you can work these in decimals or fractions or even percentages, whatever works best for you. So I've got a second one here, 50 people as their favourite music. I will leave it there for a moment for you to have a look at and then give it a go. Then I will go over it for you. Okay, I'm going to go over this now. So what I'm going to do is I'm going to start off by just filling out this table again. So I've got 50 people asked. I'm going to work out their relative frequency. So I've got 9 over 50, 10 over 50, 8 over 50, 14 over 50, 3 over 50, and 6 over 50. And then I'm going to write them as their decimal. So this will be 0.18, 0.2, 0.16, 0.28, 0.06, and 0.12. Okay, so they're their relative frequencies, and to check it, you can always add them up and make sure it equals to 1. So now, those actual, what's the probability of? So, what's the probability that someone likes hip-hop or dance as their favourite music? Hip-hop or dance. So, what you'll do is you'll take, because we're using OR, that means addition. So, we look at our hip-hop, which is 0.2. And add it to the dance, which is 0.18. We're going to add those together. Hip hop or dance is 0.38. Now, next one, we got pop, rock, or classic. So let's take these probabilities. So we've got 0.28. That is our pop. No, 0.16. So 0.16 for our pop. Our rock is 0.28, and our classic 0.06. So you take those three probabilities, because it's OR again, you're going to add these all up. So what we want here, so that and that, 0.22, add this one here, we get 0.5. Okay, 0.5 for that there. And then final one here, calculating some probabilities. We want not rock or other. So that means not this one, not this one. So you could add up the other three or the other four. 1, 2, 3, 4. Or you can add these two up and then minus it from 1. And that's what I'm going to do. So I'm going to do 1 minus my rock, which is 0.28. Add 0.12. So that gives me 1 minus 0.4. So it gives me a probability of 0.6. Okay. And then looking at the final problem here, if 250 people were asked, how many do you expect to like classic or other? So classic or other. So we've got those there, classic, other. So I'm going to start off, because I want one or the other, I'm going to do 0.06, add 0.12, which is 0.18. If you hear any noises, that's my budgie in the background talking away. Okay, so we've got that probability of classic or other. Now from here, we're going to do 250 multiplied by 0.18, and that gives us an answer of 45. So 45 people enjoyed classic or other, and that is using and applying relative frequency or experimental probability.